Okay, so we're going to talk about scatter plots and regression equations. So we're going to start with scatter plots. And scatter plots are just graphs that just graph ordered pairs. There's a bunch of little dots. And so they can form like four different relationships. Actually, there's more than four, but there's only four we're going to focus on in Algebra 2. So let's start with the linear. Try it again. And if there is a linear relationship with your scatter plot, it should form a line or something close to a line. Now, none of these are going to be perfect. So there might be some points kind of like out of position, but in general, overall, it forms a line. What do you think the quadratic is going to form? What's the shape of a quadratic? Do you guys remember? A U, a parabola. So a quadratic will be something like this. Or it could be an upside down U. All right, and then these two at the bottom are new. This year, they're not ones that you had learned about in previous classes, I don't think. But for exponential, I'm actually going to fit in two little graphs here. One is going to be exponential growth, and the other is going to be exponential decay. All right, so exponential growth is going to kind of start out flat and then go kind of steep upward. And then exponential decay starts steep and then kind of goes flat. Those are both examples of exponential scatter plots. All right, and then logarithmic is another one that this year is the first year you've heard anything about logarithms. So you may or may not remember what those graphs look like. But they're going to kind of be this shape. All right, so this worksheet has tons and tons of like steps, calculator steps, and I tried to find a good way to organize the steps, and it's still kind of hard to follow. But the first example we're going to do is we're going to take this data that represents the depth of the water is this, and then the temperature of the water at that depth is what the T is. And we're going to look at the scatter plot and decide if it's linear, quadratic, exponential, or logarithmic. And so right above this are all the steps to look at a scatter plot. And so the first step is to enter the data. All right. And so what you're going to hit is stat, and then you're going to hit enter. All right. So stat is right beside where the arrows are. And when it comes up, it's just edit, and that's what you want to do. To put in the data, you're going to edit. So then you're going to just hit enter on 1. Now, you probably have some stuff in your calculator from the previous class, unless it's a calculator they don't use. But we're going to start off and clear out these lists. We are not going to delete. We're going to clear. So what you do to clear the list is hit the up arrow. So like either L1 or L2 is darkened. And then you're going to hit clear and then enter. All right, and then we'll go over to list 2 and do the same thing. Go up so the list 1 is darkened, and then hit clear. Please don't hit delete, and hit enter. Now, if you accidentally delete a list, I can get it back, but it's some work. Did you delete a list? Okay. Try not to delete a list. It doesn't come back when you reset the calculator. You have to do some other things. I don't know. It's okay. It's fixable. It's just kind of annoying. All right. So everyone have list 1 and list 2? All right. So what we're going to do is enter the X values in list 1 and the Y values in list 2. Now, this particular table, instead of X and Y, we have D and T, but that's fine. We're just going to basically put this table exactly like it looks on list 1 and list 2. So you hit the number, 0, enter, and then 4, and then enter. So we're just going to go down that list. Make sure you hit enter after the 15. All right, and then you'll hit the over arrow and do the same thing list 2, put all of these numbers that are underneath the T. Hitting enter after each one. Okay, so I'm just double checking I didn't mess something up. Okay, so that's entering the data. Now, we're going to have to enter the data in every single problem we do today. So it's in there in list 1 and list 2. And now when you're asked to graph a scatter plot, these are the steps we're going to follow. All right, so we're going to start off and hit second and then Y equals. Now, if the person in your calculator who used your calculator last class already did this, it might already be done for you. But when you hit second and then Y equals, this pops up. All right, we're going to hit enter on number 1. And then we're just going to hit enter on the word on. It might already be dark, and that's okay. All right, now after you do this one time, unless you reset your calculator, it's going to stay turned on, so we won't have to turn it on every time. All right, and then to get a scatter plot, we're going to hit zoom, and then we're going to hit 9. So zoom, and then 9. All right, so yours should look something like mine. If something is wrong, let me know. All good? Wow, it's a calculator miracle. Okay, so what do you guys think? Out of those 4 different types of scatter plots, what does it look like? Linear, good. So that's the answer to part A. All right. And then part B says to find the appropriate regression equation. So let's talk about what a regression equation is first. So a regression equation, or a line of best fit, is the equation that best models the data. All right, and then this equation can be used to make predictions. So to do part B, our directions are down here for regression equations. It tells us to enter the data. Do we need to do that again? No, it's already there. We don't have to put it back in there again. So we're ready to do all this stuff. So we're going to start off and hit stat. No, you can. But I think you can just hit stat and it's fine. All right. And this time we're going to go over to calc. And there's a ton of things under calc. I don't even know how many things. But if we want to do what the best fit for the one we just said, that was linear, we're actually going to choose number 4. I'll write that down in just a second. So we're going to choose number 4 for a linear regression. All right, so we chose the appropriate. Now we're going to hit enter several times. So just keep hitting enter till something different pops up. There it is. All right. Now what this is it tells you like the base model for a linear equation. So that y equals ax plus b is like the base. And then it tells you what to put in for a, and it tells you what to put in for b. So up here at part b, it's going to be y equals, and then we're going to put negative 0.61 in for a, and then they all have to have an x. If they don't have an x, it's not quite going to work. And then we're going to put in 84.85 in for b. All right, and that's my equation. So over here beside part A, we're going to do for linear regression, it's number 4, and it says lin reg. So I think in our notes we'll do all the different types so we'll know how to do it. Okay, and then part C asks us to use the regression equation to predict the water temperature of the lake at 22 feet. So what are we going to do with that 22? Don't know. We're going to put it in for x. X is 22. So we'll take that equation we just found, and we're going to put 22 in for x. Okay, so that means that it's going to be 71.43 degrees Fahrenheit at that depth. Oops. Up. Right, so that's basically what we're doing today. Now, sometimes, we're going to pick different types of regression, but that's what we're doing. Okay, so it might not feel super comfortable yet, so it's okay. We're going to do several more examples. All right, so example 2 is a finance question. So the table to the left shows the closing prices for the NASDAQ index at the end of February during certain years. We're going to look at the scatter plot and determine if it's linear, quadratic, exponential, or logarithmic. Now, hold on before you start putting the data in. Hold on just a second. Sometimes when you have these years, they get too big that your calculator gets overloaded and it won't work. So instead of 1992, we're actually going to put in 2 for 1992. And then we're going to put in 4 for 1994, and then 6, and then 8. And then what do you think we put in for 2000? 10. All right, that's the table we're going to put into the calculator. All right, so when we need to put the data in the calculator, you hit Stat, you hit Enter on number 1, and then this is where we're going to put it. First, we're going to clear out the list by going up, hitting Clear, and then Enter. All right, and again, we're not putting in that whole year because it will overload the calculator. Oh gosh. There we go. All right, that was a struggle for me for some reason. Let me just make sure I didn't mess it up. All right, I think we're good. right, and we already turned that scatter plot on, so that's not something you have to do again. So we can just go ahead. Whoops. We can just go ahead and I think hit zoom 9, and there it is. There's our scatter plot. So we're deciding between linear, quadratic, exponential, or logarithmic. What do y'all think? This is exponential. Very good. Okay. Part B asks us to find the appropriate line or curve of best fit. So we want the exponential regression. So we're going to hit Stat. We're going to go over to Calc, and we're going to start scrolling until we see something that we think is exponential regression. What do y'all think? 0? Yeah, 0 definitely means exponential regression.
What do we do to get that edit?
So you hit Stat, and you go over to Calc, and then we're going to scroll to exponential regression, which is 0. Okay, and then we'll hit enter a whole bunch of times. Right, and then it shows you the model, and then it tells you what to put in for A and what to put in for B. So we're going to put about 320.28 in for A. B is the base, so I'm going to put it in parentheses. You don't necessarily have to. And then it's raised to the X. Right, and then for part C, we want to use that model to make a prediction about 2003. So what are we going to put in for X for 2003? So 2000 was 10. So 2003, we're going to put in 13. So it should stop or should close at 7,161. I'm going to go ahead and round. I don't think it closes at decimal points, but it's okay. Okay, we have a couple of more that we're going to do. Now, these we're not going to have to do the scatter plot. So I made it bold so you can tell that this one we're going to do logarithmic model, so we don't have to do the scatter plot. And then this one's going to be a quadratic, so we don't have to do the scatter plot. But we are going to have always put in the data. You have to always put in the data. So this model gives the percent of all workers who are female during the, not years, but during the years, from 1970 to 2006. We're going to do a logarithmic model. So this is another case where we cannot put in 1970, 1980. It just will overload the calculator. So we're going to do 70, 80, 85, 90. And then what do you guys think we'll do for 2006? It's going to be 106. If you're doing 70, 80, 85, then that has to be 2006. Okay, let's put that in. Okay, so it's always stat and then enter on edit. We're going to need to clear out these lists by hitting up, clear, enter. I did, thank you. Did not mean to make that 700. It's going to be way in the future.
Where did he get the 65 from?
I'm just typing in weird numbers. I think it's because I can't see. I'll go back and fix it. 35.3. All right, and this last one. 41.4. Okay. And we know that this is going to be logarithmic, so we don't have to look at the scatter plot to figure it out. So what we'll do is we'll go back to stat, over to calc, and then let's find logarithmic. All right, so, oops. All right, people get confused and think logistic is logarithmic. It isn't. So ln is logarithmic. It means natural log. So anytime it's logarithmic, you're going to choose number 9, which is that natural log regression. So we're going to choose 9, and then we're going to enter. And then it tells us the base model, and then it tells us what to put in for A and what to put in for B. All right, I think there's more to this equation than just, or more to this problem than just the equation. We're going to write, okay, we did that. Then estimate the percent of female workers in 2016. All right, so 2006 was 106, so 2016 should be 116 that we put in for X. Okay, so we'll just start typing that in. So natural log is the button right beside the 4. Okay. So it looks like about 44.56% of women, of the percent of all workers are women. Come a long way from 1970 for sure. Go back to what? Oh, in the calculator?
We do the same thing, but I got for A, it was like 21.
Okay. I'm wondering if you didn't pick natural log. I'll look at your calculator. Everybody else, go ahead and put this data in for example 4. Put it in the calculator. Even though it's horizontal data, go ahead and do it vertically. So all of these numbers put in list 1, and then all of these numbers put in list 2. Okay, so this one, Sarah is standing on a bridge that stands 50 feet above the water. She tosses a coin into the water. The height, which is H, which is list 1, of the coin at time t seconds, sorry, the height is list 2, and then seconds is list 1, are given in the table. We're going to do quadratic regression. So that's our data. And then we're going to find the height after 3 seconds. All right, so for quadratic regression, we're going to hit stat. We're going to go over to calc. And anytime we're doing quadratic regression, it's going to be number 5. Okay, and then we're just going to hit a whole bunch of enters. Okay, and same thing. It's a totally different type of equation. It's a quadratic equation, but it tells us what to put in for A. So it goes in front of x squared, B goes in front of x, and then C goes in front of, or sorry, C goes at the end. Right, and then the question asked us to predict the height of the coin at 3 seconds. So we'll go and put 3 in for the x's. Okay, so it looks like at 3 seconds, the coin is 14 feet above the water. All right, what questions do you guys have? I know it's a lot of calculator strokes today. Yes. This one?